So hello everyone. Today we will see a course about the memory, internal memory in computer. There are many levels of memory. We can see the first level is the cache, the memory which is communicate directly with the microprocessor, and the second level, the RAM, the DRAM. The cache is an SDRAM, static RAM, which is fast. And the microprocessor need a fast memory. So the cache, which is SRAM, made by the technology static random access memory. This is first level. Second level is the dynamic RAM, dynamic random access memory. And the third level we can say hard disk, CD-ROM, and so on, including memory flash and so on. So today we'll talk about the memory cache which is nearby the microprocessor. It could be just beside the microprocessor, or could be sometimes even inside the microprocessor if the cache size is small. So in this course we talk about cache mapping. Because why? What is cache mapping? Cache mapping is necessary because the microprocessor is fast and need to communicate only with fast memory, fast RAM, and the dynamic RAM is not very fast. So microprocessor do not communicate directly with the dynamic RAM. Microprocessor communicate with static RAM. And auxiliary memory like hard disk and CD-ROM and so also need to be copied. The required data need to be copied inside the dynamic RAM. And then following the mapping process, we need to copy following using algorithm and program compilation. We prepare the data that need to be required data that needed by the program, and this data must be copied in the static RAM. That is cache memory, which microprocessor work with. So the mapping, the way how to copy the data from the dynamic RAM to the static RAM, which is the cache, is called mapping, a mapping technique or mapping method, like you see here, cache mapping technique. So there are three main methods for cache mapping, like you see here. So there is direct mapping. So it's not complicated. We took the data in the specific order, in the unchanged order, and we copy some segment by segment the required data. So the dynamic RAM, so the main memory, we can say the central memory or the main memory, which is the dynamic RAM, could be divided into many segments, and this segment size is exactly the same size of the cache. So we can call them pages. So each page, each amount of data, which is a segment, we can call it page. And these pages, there are many pages in the dynamic RAM, and one page, every page has a number. So the cache, we will fill the cache with one page. And the current page filled in the cache is the number of the page. This is important because when we look for information, we need just to know the page number, called tag, like you see in the slide. Here is tag. Tag is, we can say, the page number. And this procedure to identify the data by tag is also the same. We do the same way for fully associative and K-way set associative mapping. So direct mapping, we copy directly the data from the dynamic RAM, but with a normal order and the segment. And but for cache, fully associative mapping,